Hello everyone, welcome back to our YouTube channel. This is the Easy QS channel where we deal with building, quantity surveying, civil engineering concepts, preparing students for exams. And today we will be doing mathematics. This is an area that most of you asked for, and we will be looking at the area of calculus. So today we will be having a mathematician on board, and he will be taking us through step by step so that we can be able to prepare for our calculus exams, especially for module 2 students in diploma in building and civil, together with those who are doing craft and building module 2. This is a very examinable area. So we shall start from the beginning. We will go step by step until the end. We hope to help you to understand in so much detail the area of calculus, trying to bring it in the simplest way possible. So if you're new to our channel, kindly subscribe. This is a channel where we will help you prepare for exams. We'll help you if you're done with school and you need some refresher on the area of quantity survey, estimation and costing. Here is the right place. If you've been coming back to our channel and you haven't subscribed, kindly do it. That one is that support that we need so that we can continue making content for you. For all those who need tutorial classes, remember to send me an email on my email. And also, if you have any question in this video, write it in the comment section and we'll be able to answer all your questions. So for all your questions, write them in the comment section. If you like this video, if you like this content, remember to give it a thumbs up. And if you haven't subscribed, remember to subscribe. And we will be starting live classes very soon, especially on the area of measurements. So keep tuned, be coming, asking all your questions. And in case you have any issue that you would want us to cover, remember to communicate. So welcome so much, Mr. Evans, for today's class. And kindly take us through.
Okay, hello everyone. Today you're going to focus on the area of mathematics, on the topic of calculus, more so in the topic of the subtopic on differentiation. Differentiation. And so in this subtopic, we're going to look at the following outcomes. We're going to look at number 1, define the rate of change. And number 2, we are going to be able to find the gradient of the curve. And number 3, we're going to look at the differentiation of a function. Differentiation of a function from the first principles. And number 4, our final task of today, we're going to find the derivative. Of sin x and cos x using the first principles. So welcome, and I hope you enjoy the lesson. From our first objective, we're supposed to define the rate of change. We're supposed to define the rate of change. The rate of change. And then here, in this case, we are going to remember some of our concepts we learned in our previous levels. That is the equation of a straight line. The equation of a straight line. So the equation of a straight line is given by this formula. That is y is equals to mx plus c. Where now m here stands for the gradient and c stands for the y-intercept. So, how do we get the gradient? Gradient is given by the change in y over change in x. Change in x. For example, given a straight line, passing through points A, given by the following coordinate 2, 3, and B 4, 6, you're asked to find the gradient and y-intercept of the said line. So you are going to be able to use those two coordinates, A and B, to be able to find the gradient of that line. So we are given point A, 2, 3, and point B, 4, 6. And we have seen iron that gradient M is given by the change in y or over change in x. So you're going to take the y value of the coordinate. Remember, 2 is the x coordinate and y is the y coordinate. Same case applies to b here. So change in y, you're going to take the value of y in our second coordinate minus the value of y in the first coordinate. So it will be 6 minus 3. Then change in y will be 4 minus 2. This will give us 3 over 2. The other one's 1.5 or 1.5. Therefore, this is our gradient. Then how do we get our x, our y-intercept? Having the gradient m is equals to 1.5, then you have one of the coordinates of that line, that is A, is 2, 3. Then we assume the coordinates of the other point, let's say point C is equals to xy. Then you're going to form the equation of that line, then you're going to be able to extract the y-intercept of that line. So in this case, our gradient will be 1.5 is given by change in y, should be y minus 3 over change in x, x minus 2. Then if you cross multiply this equation, you're going to have y minus 3 times 1 is y minus 3 is equals to 1.5 multiplied by x minus 2, which will be y minus 3 is equals to 1.5x minus 3. you bring the right terms together, it will be now y minus 3, will be y is equals to 1.5x minus 3 plus 3, which will be equal to 0. So that is our equation of that sign. That is y is equals to 1.5x plus 0. Therefore, from our general equation of a straight line, that is saying y is equals to mx plus c, and the c is given as the y-intercept. Therefore, in this question, our y-intercept will be equal to 0. Our y-intercept will be equal to 0. Therefore, we can say that the change in y over change in x has been able to give us the gradient. And now from that explanation, you can be able to get now what we refer to as the rate of change. Now the other point is, I said earlier that we were supposed to look at the gradient of a curve. The gradient of a curve. These are just the preliminary introductions of this topic before we go to the actual concepts. So, the gradient of a curve. The gradient of a curve. And we have this statement to put across. The gradient of a curve at any point is a gradient. Is a gradient of a tangent is the gradient of the tangent to the curve at that point. So that is a very important statement to put across when you're going to be looking at the gradient of a curve. That the gradient of a curve at any point is the gradient of the tangent to the curve at that point. And I'm going to illustrate using this drawing. If you have a curve, there's these 3 points. There's point A, point B, and point C. So if I to find the gradient of curve ABC, from our definition there, we are saying that it will be the gradient of the tangent. Now we have to draw a tangent at point B. This is how a tangent is a straight line cutting across point B. We can name that point BP. So BP is the tangent. So when we find out the gradient of this tangent, BP, you will be assuming given the gradient of this curve ABC. And for us to understand more, let us go to the next objective of the day that we are supposed to check. That is now differentiation. Differentiation. This is the first part of a calculus. The first part of calculus. And we can define this one by saying that differentiation, this is a process. This is a process of finding the gradient of a curve at a particular point. The process of finding the gradient of a curve at a particular point And by saying that, we start from the first method of differentiation, that is called differentiation from the first principles. Differentiation from the first principles. So we are going to dwell much here because it is a very major part in differentiation, in calculus. So, and I'm not going to derive the formula, I'm just going to give the formula. I'm just going to give the formula. So you can say the gradient of the curve at a point is represented as the first one is, you can either represent the gradient of a curve as the limit of small change in y. This stands for the small change in y, which is read as delta y. So you find this a symbol that means delta y, which refers to a small change in y. So the gradient of a curve at a point can be given as the limit of delta y all over delta x, all over delta x. So this stands for small change in x. It's read as delta x. We can also represent the gradient of the curve at a point as dy of dx, which is read as, is read as dy by dx. Then the other way we can represent the gradient of a curve is by this formula, that is the limit of delta y over delta x as delta x approaches 0 will be given by the limit as delta x approaches 0 of the function, the f of x plus a small change in x minus f of x all over the small change in x, or delta x. And this is what we call now differentiation from the first principles. This is what we call differentiation from the first principle. So the moment you are asked to find the integral, to find the derivative of a function using the first principles, this is the formula to use. This is the formula to use. That is the limit of delta y over delta x as delta x approaches 0 will be equal to the limit of the function f of x plus a small change in x minus f of x all over delta x as delta x approaches 0. That is the formula to use when you are trying to differentiate from the first principles. So let us look at an example and see how that formula is applied. So our first example we are trying to differentiate from first principles. The function f of x is equals to 2x squared, and find the value of the gradient. Find the value of the gradient of the curve. At x is equals to 2 and x is equals to 4. So that is our question that we are supposed to undertake to be able to apply that formula. Differentiation from first principles. So to differentiate from first principles, it means that we are finding dy of dx, which is given as f dash of x, in other words, f prime of x. This is finding the derivative of a function. Therefore, using from the first principles, this is the formula that the limit of the function f of x plus a small change in x, in the function f of x, or a small change in x as small change in x approaches 0. That is the formula that we're going to use. And we're given f of x as 2x squared. So we have f of x as 2x squared. Therefore, we're supposed now to find f of x plus more change in x. So f of x plus more change in x will be given by, so from our function f of x, where we have x, we are going to replace it with x plus more change in x. Let me repeat that. From our function f of x, now to find f of x plus more change in x, it means that from this function 2x squared, where we have now x, we are going to replace it with this x plus more change in x. So f of x plus more change in x will be 2. Now instead of us now writing x squared tunaandika x plus more change in x squared. Then now we are tasked to expand that. So this will give us x plus delta x squared, means x plus delta x times x plus delta x. Let's give some space here for us to be able to calculate that. So we want to expand our x plus more change in x x plus small change in x. So you're going to take this x here, multiply whatever is in the circled bracket, x plus small change in x. Then here you are left with plus delta x. It also multiplies the other bracket, x plus small change in x. So let's multiply here. It will be x times x will be x squared plus x delta x. Remember, delta x is one unit. So you can separate delta x to be delta x as it is. So when you multiply x times delta x, it will be x delta x plus x delta x plus delta x times delta x will be delta x squared. We can put it the bracket in that way. So then we bring the like terms together. It will be x squared plus 2x delta x plus delta x squared. Then remember, our f of x plus delta x was 2 into bracket x plus delta x squared. So we have to multiply this function again with 2. It will be 2 to bracket x squared plus 2x delta x plus delta x squared. So when we multiply by the constant 2, it will be 2x squared plus 4x delta x plus 2 delta x squared. Now we go back again to our formula, which we stated as the limits of the function f(x plus delta x minus f of x over delta x as delta x approaches 0. This is the formula we use when you are finding the derivative of a function using the first principles. We have our f of x. We also have f(x plus delta x, which will be now the limit as delta x approaches 0. F of x plus delta x, we have it here. So it will be now 2x squared plus 4x delta x plus 2 delta x squared. Then we have minus f of x. F of x was the parent function, which was 2x squared minus 2x squared over delta x. So you have been able to replace the formula with the actual values from that question. As you can see, if you now bring the like terms together, this 2x squared and this 2x squared, they're going to add up to 0. So you're going to be left with the limit as delta x approaches 0 of 4x delta x plus 2 delta x squared. This one and this one are added up to 0 over delta x. So this means to be the limit as delta x approaches 0. So we can do we have delta x here and delta x here. So we can factor it out because it's common to be delta x to bracket 4x plus 2 delta x over delta. Okay, from this expression here, we can see we have the limit of the function 4x delta x plus 2 delta x squared over delta x as delta x approaches 0. From here we can see we have a common factor, which is delta x. So we can separate delta x outside the bracket to be in this format. The limit of delta x approaches 0 of delta x into bracket. You can also say 2 delta x, because 2 delta x is common in 4x delta x and 2 delta x squared. So we will be left with 2x delta x, 2x plus delta x over delta x. So having said that, then you can be able to cancel out this operator delta x and delta x1 and delta x1. So we are left with limits as delta x approaches 0 of the function 4x plus 2 delta x. Then from this statement here, as we can say therefore as delta x approaches 0, then our function here 4x plus 2 delta x so will be given by, this will be, so where we have delta x, we insert 0. It will be 4x plus 2 delta x. Now it is 2 times 0, which will be 4x plus 0, which is 4x. Therefore, the f prime of x is equals to 4x. So we have been able to differentiate the function 2x squared from the first principles using the formula that we have written down to add up to this function. That is f prime of x is equals to 4x. Then there were subsequent questions that was accompanying that middle question. You are told to find the gradients of the curve at x is equals to 2. At x is equals to 2. So in other words, 4x is our gradient. 4x is our gradient of the curve of the function 2x squared. So at x is equals to 2, at x is equals to 2, this will be the same as 4 times 2, which will be 8. So the gradient of the curve 2x squared at the point x is equals to 2 will be given as 8. Then the gradient of the curve at x is equals to 4 will be given by 4 times 4, which is 16. Therefore, the f prime of x and x is equals to 4 will be equal to 16. So that is how you find the gradient of a curve, or what you call the differentiation of a function using the first principles. So we proceed and So from our first objective, that is a differentiation from first principles, our task now is to derive the formula. Our task is to derive the formula. So you're going to consider a curve which has 2 points, P and Q. Consider 2 points P and Q that are on a curve as shown. We're going to sketch this curve. This is the y-axis, is the function x, and this is the x-axis. Then we have a curve like that, which has these 2 points, point P and point Q. So point P is here, and the coordinate for point point P will be the coordinate of x, the coordinate of y, that is x, y. Then we have point Q, here, Q. We're going to give the coordinate later and see how it comes around. So if we drop this line to meet the x-axis, this point will be A. Then we also from point Q drop this line to meet the x-axis. This point will be, let's say, B. From point A to point P, this distance is given by f of x. F of x, since it is on the y-axis. Then from point P, if you produce a line to cut the line joining Q and B, let's say this point is C, give it point C. So from A to B, that is this distance from point now A to point B. So this distance will be given by, it is a change in x. A change in x. Since the coordinate of P was x, y, x are along this line, so this distance from point P to point C is an increment in x. So it will be given by that symbol. This symbol is delta x, which means a small increment in y. Then from point from point Q to point B, this distance is given by f of x. You can see f of x is here, plus, now from point P to point Q, there is an increment in x, so plus that delta x. So from Q to B, that distance can be given by f of x plus delta x. Then from point C to point Q here, this distance is now delta y, the small increment in y. We are comparing these 2 points, point P and point Q. From point P to point Q, there's an increment in the y-axis, or the y-coordinate. That is why we are given this distance to be delta y. Then from point Q to point P, there's another increment in x. You are given it the notation delta x, small increment in x. Small increment in x. So that symbol means delta x, which is a small increment in x. Same case applies to delta y. It's a small increment in y. So now we find the gradient of this curve PQ, the gradient. So PQ, the gradient of curve PQ will be given by change in y over change in x. So change in y or change in x, and this change in y is given by the small increment in y over small increment in x. That is delta y over delta x. And remember, delta y will be given by y plus delta y minus y. That is y plus delta y, that is now the new y minus the original y to give us change in y. So then delta y can be written as a function of x. As a function of x. That is now delta y given by y plus delta y minus y, which is the same as the f x plus small change in x minus f of x. That is now the small increment in y. Then now what we said earlier on that when you're finding the gradient of a curve is like you're finding the gradient of a tangent at a point along the curve. Therefore, the gradient. So if we join point P and Q, that line that joins P and Q is called a chord. So the gradient of chord PQ, this now line, this gradient, will be now given by change in y over change in x. That is now change in y over change in x. The small increment in y gives us the change in y. The small increment in x gives us the small increment in x. So we are finding the gradient of this chord, point PQ, the line from P to Q. What is the gradient? It will be now the change in y over change in x. Change in y here is given by delta y. Change in x will be given by delta x, which is there. And delta y is given by this. So delta y over delta x will be given by f x plus delta x minus f of x over delta x. Delta x. That is now the gradient of the chord from point P to Q, from point P to Q. So now, when we let now delta x to approach 0, so when delta x is going to near 0, the gradient of chord PQ approaches the gradient of the tangent at P. So in simple, what it means that we add the chord PQ And this is how we find its gradient. So we are saying that as this small change in x nears 0, then the gradient of PQ will also approach the gradient of the tangent at point P. Then still as delta x still is going to approach 0, as delta x is going to approach 0, this value delta y over delta x, or the gradient of the cone PQ, is going to approaches a limiting value, approaches a limiting value. So it's simple. Having now this equation for the gradient of a cone PQ, where we are saying that delta y over delta x will be given by f of x plus change in x minus f of x over delta x. When delta x is going to approach 0, we are saying the gradient of the cone PQ, this now, is going to approach the gradient of the tangent at point P. Then when the same delta x is going to approach 0, this equation of the gradient is going to reach a limiting value. It's going to reach a limiting value. That is now why we write now the final equation as this, as the limit as delta y over delta x, as delta x approaches 0, will be given by the limit as delta x approaches 0 of the function f x plus delta x minus f of x over delta x. And this is what we called, as differentiation from first principles. Differentiation from first principles. That is a formula for differentiation from first principles. We proceed and look at another example. So we are told to find an example, find the differential coefficient of f of x is equals to x cubed over 3 from the first principles. So when you have a such a question, you simply have to remember the formula of differentiation from first principles. And the formula is given by y prime is the same as dy of dx to be given by the limit as delta x over delta x as delta x approaches 0 of the function f x plus delta x minus f of x over delta x. So that is the first step. You must remember the formula. From the formula, we can be able to identify f of x from our question. F of x is given by x cubed over 3. X cubed over 3. Then, for us to be able now to get now f of x plus the small change in x, where we have x, we replace with x plus the small change in x. So we have x cubed. So x cubed will be the same as x plus small change in x cubed over 3. Over 3. So having taken that equation now, then we have to solve for this. So you solve x plus delta x cubed. You solve that first. So you're going to have to expand that. That is x plus small change in x times x plus small change in x times x plus small change in x. So we work out this first. So when we expand to be x multiplied by x plus small change in x plus small change in x, x plus small change in x. So we multiply here, going to have x times x is x squared plus x small change in x plus x small change in x plus delta x squared. Then the next terms together will be x squared plus 2x delta x plus delta x squared. Then now this one you multiply by x plus delta x. So which simply means we expand again to be x times x squared plus 2x delta x plus delta x squared plus delta x squared plus 2x delta x plus delta x squared. If you remove the bracket here, we are going to have x cubed plus 6x delta x plus x delta x squared plus x squared delta x plus 2x delta x squared plus delta x cubed. So if you bring the right terms together, you're going to have x cubed plus 6x delta x plus 2x delta x squared plus x delta x squared then plus delta x cubed. That is now our function fx plus delta x. So then we're going to replace it now from the formula. We replace that function now in the formula. So you're going to have now the limit of delta x, delta y over delta x as delta x approaches 0 for the function now. When now we end f x plus delta x will be replaced by that x cubed plus x cubed plus what? So we need to check if we have made a mistake somewhere here. So a mistake here. So this is x times x going to be x squared plus this one is 2x squared delta x plus x delta x plus x squared delta x plus 2x delta x squared plus delta x cubed. So which will give us here some mistake here. We need to rectify. We're going to have x cubed plus 2x squared. This and this are similar. You can add them together. You're going to have plus 3x squared delta x plus again this and this are similar plus 3x delta x squared plus delta x cubed. So now this is what now is the same as f of x plus delta x. So we're going to have x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Remember, minus f of x was x cubed. All these over 3, then over delta x according to our formula. So that is now, we have replaced now f of x plus delta x from into the formula, and guess what we have? Is what we have. So simplifying that, we're going to have the limit as delta y over delta x. Delta x is going to approach 0. We're going to have x cubed over 3, needing to separate them, plus 3x squared delta x over 3 plus 3x delta x squared over 3 plus, put some space here, plus 3x delta x squared over 3 plus delta x cubed over 3 minus x cubed over 3. So all this over delta x. So we're going to have the limit as delta y over delta x. Delta x is going to approach 0 of this function, So we're going to have x cubed. If you can see this one and this, they are the same. So you subtract x cubed over 3 minus x cubed over 3, you're going to have 0. So you're going to be left with 3x squared. You can cancel here, because the bracket can cancel by 3, 1, by 3, 1. Even here can cancel by 3, 1, by 3, 1. Even here by 3, 1, by 3, 1. So this one and this one, they're going to add up to 0. So we're going to be left with x squared delta x plus x delta x plus x delta x squared. So we're going to have x squared delta x plus x delta x squared. So repetition here. So you remove 1 here. We're left with delta x cubed over 3. This one now over delta x. Okay, so we have delta x on each of the factors there. So we can sample it out. We'll be left with the limit as delta x approaches 0 over delta y by delta x. So delta x will be outside the bracket, will be left with the x squared plus x delta x plus delta x squared over 3. All this over delta x. This one we're going to cancel out, and we'll be left with the limit as delta x approaches 0 of delta y over delta x. Be left with x squared plus x delta x plus delta x squared over 3. That will be, after you cancel out delta x, you do the similar, we'll be left with that. Then we say as delta x approaches 0, we're going to be left with x squared plus x times 0 plus 0 squared over 3. So we'll be left with x squared. Therefore, f prime over x will be equal to x squared. That is the derivative of the function x squared cubed over 3 given by x squared. So another example, this one will be, in this example, we are finding the derivative of a function which is a constant. You are trying to find dy of dx of f of x is equals to 5 using the first principles. Using the first principles. using the first principles. So the formula still remains limit as delta y over delta x as delta x approaches 0 of the function f of x plus delta x minus f of x all over delta x. We know f of x is equal to 5. F of x is equal to 5. Then f x plus delta x will give you 5. Will also be equal to 5 because 5 is a constant. So the dy of dx will be equal to f prime of x because the limit as delta x approaches 0 of 5 minus 5 over delta x. Remember, f x plus delta x will be equal to 5 and the f of x is equal to 5. Therefore, there will be the limit as delta x approaches 0 of 0 over delta x, which will be 0. Which now will come up to, when we're going to look at the standard integrals, sorry, not integrals, but derivatives, the standard derivatives, the derivative of a constant is equals to 0. Is equals to 0. As we move on this subtopic, we're going to read you some exercises. You can check them later. So find the derivative of the functions using differentiation from first principles. So number one, we're going to find f of x is equals to 1 over 2x. Number two, f of x is equals to 4x squared plus 6x minus 3. So those two examples, or those two exercises are going to give you some work to be able to remember the formula. So then from our objectives of the day, we were supposed to cover the differentiation from first principles of a sine function and the cosine function. So we're going to differentiate of a sine function. And here you are using the first principles. So f of x is equals to sine x, where x is in radians. So we've been able to follow through the process of our differentiation using the first principles of functions that are not sine or cosine. Now we want to look at the function sine. How do we differentiate that function sine? Using differentiation from first principles. And remember the formula remains. This is our formula. The limit of delta y over delta x as delta x approaches 0 of which function? F x plus delta x minus f of x over delta x. That is our formula that we use to differentiate any function using first principles. So our f of x is equals to sine x. Then f of x plus delta x will be equal to what? We say that where we have x, we replace with the x plus delta x. Therefore, f of x plus delta x will be given by sine x plus delta x. Sine x plus delta x. This now will give us the limit as delta x comes to 0 of dy delta y delta x, or the function will be now sine x plus delta x minus sine x over delta x. Looking at this, it takes you back to trigonometry. That is the double angle formula. So it means sine x plus delta x from the double angle formula, this is the same as sine x cos delta x plus cos x sine delta x. So which now will be given as this. So we're going to have the limit as delta x approaches 0 of delta y over delta x. So we're going to write sine x cos delta x plus cos x sine delta x minus sine x according to our formula of delta x over delta x. So looking at this expression here, it is not very easy to solve this. It is not very easy to solve that. Therefore, we define another function. So we can say we define f prime of x, which will be given by the limit minus so since we cannot be able to solve sin x cos delta x plus cos x sin delta x minus sin x in our normal procedures or normal methods, then we introduce another concept, or we introduce another function, which is f prime of x, which will be given by the limit of the function f of x plus delta x minus f of x minus delta x over 2 delta x as delta x approaches 0 This now is going to give us this. Our function f of x remains. F of x remains. So f prime of x will be equal to the limit as delta x approaches 0 of sine, here now, x plus delta x minus sine x minus delta x over 2 delta x. That is where we are. We proceed. So having that, you are going to have the limit as delta x approaches 0, delta y over delta x, the function here. Still using the double angle formula, I'm going to have, this one will be sine x cos delta x plus cos x sine delta x minus this one now sine x cos delta x minus cos x sine delta x. This one now over 2 delta x, or 2 delta x. So from the properties of our trigonometry, we're going to have, this will be the limit as delta x approaches 0 of now 2 cos x sine delta x over 2 delta x, which will be equal to this 2 and this 2 are going to go to cancel out, be left with cos x. Remember, you cannot be able to cancel this one and this one. They are so independent. So we are going to be left with, now we separate cos x sine delta x over delta x, which will be now the limit of cos x sine delta x as delta x approaches 0 will give us cos x, the limit as delta x approaches 0 of sine x delta x. So as delta x approaches 0, as delta x approaches 0, then that one will be the limit as delta x approaches 0 of sine x multiplied by 0, which will be equal to 1, which will be equal to 1, which will be equal to 1. Thus, cos x, then the limit as sine x by 0, delta x approaches 0, this one, you have seen this one will give us 1. So we'll be left with f prime of x is equals to cos x. F prime of x is equals to cos x. So that's how we differentiate the sine function using differentiation from the first principles, and we end up getting the derivative as cos x. So in the same breath, you can also be able to get the derivative of a cosine function. The derivative of a cosine function. That one will be your exercise to do. Using differentiation from first principles, one find f prime of x of given f of x is equals to cos x. We can work out that. So then we're going to look at some of the differentiation rules. These are going to guide us even as we move forward. Differentiation rules. So number one, we have the general rule. When we have a function, let's say f of x is given by a x raised to power n. A function of x a x raised to power 9 to power n, sorry. So what is now the derivative? Derivative is given by dy of dx, which is the same as saying f dash of x. So from the general rule it says that you take the power, you multiply by the function, but now the new power is reduced by 1. So you take the power n, multiply by the function ax m, but now the power is going to reduce by 1. Is going to reduce by 1. So when you do that, that is called the general rule. For example, y is equals to 4x squared. 4x squared. What is dy of dx? We have said you pick the power 2, multiply the function 4x squared, but now the power is going to reduce by 1. So we're going to be left with 2 times 4 times x will be 8x. The power is going to reduce by 1. Just 2 minus 1 is 1. The same as saying 8x. 8x. Then number 2 is differentiation of a constant. This one we said earlier on. That differentiation of a constant is always a 0. For example, f of x is equals to k. Then f prime of x will be equal to 0. So differentiation of a constant is equals to 0. go to the cosine and sine functions. If you're given f of x is equals to sine x, then f prime of x, it is known will be equal to cos x. It is known to be that. It has been derived, and that is the answer. Number 4, if you have a function f of x is equals to cos x, then f prime of x will be equal to, we are now, when you are here, it's like you are coming back from cos x going back to sin x. So f of x will be give you, and this will be negative sin x. So we proceed and get some the other differentiation rules. So number 5, we have f of x is equals to exponential x. Exponential x. So f prime of x will give us exponential x. Number 6. If we have a function f of x to be equal to sine ax, sine ax, so f prime of x, now the derivative would be a sine ax. Number 7, sorry. Function f of x is equals to cos ax. So the f prime of x here will be negative sine ax. Negative sine ax. So we have number 8. Exponential raised to the power ax is the function f of x. So a exponential raised to the power ax will give you f prime of x. So these rules have been derived and they have been confirmed to be true, and are very useful going forward when we're going to be looking at the different methods of differentiation. So if you're given a function, this number now 9, f of x is equal to 1 over x. F prime of x will give you ln of x. Ln of x. Ln of x. So those are some of the rules of differentiation. So this brings us now to the other objective that we are supposed to do, that is called the methods of differentiation. Methods of differentiation. And there are 3 of them. We have the product rule, number 2, you have the quotient rule, and number 3, we have a chain, or what we call function of a function. Function of a function. Function of a function. These are the 3 methods of differentiation that are going to help us be able to solve some of the problems that are going to be faced in the various exercises. Using now this method of differentiation plus the rules of differentiation, then you are at a good area or a good position to be able to solve those problems. So we're going to look at the first one. The first one for now. So the product rule. So if you're given a function of y, a function of x, which is u and v, that is u times v, where u and v are the functions of x. You are given a function f of x is equals to u times v, where u and v are functions of x. So how do we get now the derivative? So dy of dx will be given by, we are differentiating the function y with respect to x. So this is the formula. You pick the function u. The function u you multiply by the derivative of v. You add v, function v, multiplied by the derivative of u. Derivative of u. So this is our formula for the product rule. An example. Y is equals to x cubed sine x phi dy of dx. Find dy of dx. So from this function of x, we must be able to identify the function u and the function v from this expression. A function y is equals to x cubed sine x. So u, we identify u as x cubed and v as sine x. We identify u as x cubed and v as sine x. From our formula, we must be able also to identify the derivative of v and the derivative of u. So, what is du of dx? We are differentiating the function u with respect to x. From the general rule of differentiation, we say when our function like x cubed, we take the power multiplied by the function, then the power is going to reduce by 1. In other words, x cubed will be 3 times x. Another power of x is going to reduce by 1. So we're going to have 3x squared. Then dv of dx, we are differentiating the function v over or against x. Sin x will give us what? From our general rule of differentiation, we have sin x as cos x. Now you see the purpose of us writing the rules of differentiation first, because they're going to help us in this area. So applying the formula, dy of dx will be equal to u dv of dx plus v du of dx. Just applying the functions there. U is equals to x cubed times dv of dx times cos x plus v sin x times du of dx, which is 3x squared. This will be now x cubed cos x plus 3x squared sin x. Since we have x cubed and we have 3x squared, you can see x squared is common. You can remove it from the bracket. Be left with the x cos x plus 3x, the 3 sin x. And that is our final answer using the product rule. For your assignment, I'm going to give you this simple question. Find, it's an exercise. Find dy of dx of the function y is equals to x power 4 cos x. So when we meet in our next lesson, we're going to look at the other two methods of differentiation, which are the chain rule and the quotient rule. We'll meet in our next lesson.